Okay, to begin the machine, and we're talking about the Femco Durga 25E CNC turning center, the first step is to turn the master power on using this switch. When you turn that on, you will notice that there's motors start and fans inside the machine control unit that begin turning, and you can hear the motors running. Now that the main power is on at the back of the machine tool, our next step is to turn the power on the front of the machine. When we push the start button the first time, it activates the computer control unit that runs through a diagnostics process and prepares itself for successfully executing programs and commands that will be in the CNC code. We give this a few minutes to, up to a minute to initialize the computer, and then we press the button a second time. It did nothing because the emergency stop button was pressed. Turn the emergency stop off, press the button a second time, and we hear the hydraulics come on, and now the machine tool is ready to align the axes. Now, something that is important to observe when we get to this step in the process is the location of the turret. The turret is located right now at the zero return or home position, which means that if I just simply begin to zero return the machine, it's going to give me an over travel on the axis. So what I need to do is move it away from the limit switches that define the zero return position. To do that, I pick the selector switch, move it to the handle mode. I select the Z-axis using this axis selector switch. And using the hand wheel, I will move it in a negative direction. This moves the turret forward so it is off of the limit switch where the zero return is located. I then move the selector switch to the X-axis. Once again, moving it in a negative direction, I move the turret towards the center line of the spindle. With this done, I have cleared the limit switches for the zero return position. I now move my selector to the zero return, which looks like a target for an origin. I press X positive first, which begins movement. You will notice on the CRT that the axis is updating. Once it begins moving slowly, you can let go of the button and it will continue to travel. If it's moving fast and you let go of the button, it's going to stop. Next, I press Z plus. Now, when I take my finger off the button, it stops, like we just observed. If I press and hold down, as soon as it begins to move slowly, then I can take my finger off the button, and the machine is automatically going to drive the Z-axis slides so that it finds the zero return point that is factory preset and used for calibrating the measurement system of the machine tool. Now that the machine tool has been aligned, I need to look at my coordinate positions on the screen. I have three options. I have absolute coordinates, which are pictured as the default at startup. It gives me the position of the machine along the x-axis, which factory preset is x 8.00 inches. And the Z value that shows up in the CRT tells me the distance from the zero return point to the axis origin that was set for the workpiece for whatever part was being manufactured on the last run. If I select the relative coordinates, notice that I have a U and a W that show up as opposed to an X and a Z. That's because these coordinates represent the incremental distance along the X and Z axis from where the machine was sitting at power up to the zero return point. To prepare the machine for operation, I must cancel by pressing the U and cancel button, which zeroes this out, and I do the W and cancel that zeroes out the W value. So now my machine should be ready to set up. If I press the All button, it displays relative coordinates, absolute coordinates, and machine coordinates. What you will notice is that the relative and the machine coordinates are both set at 0, but you will also notice on this particular machine tool that the machine coordinates are in metric units and the relative coordinates are in inch units. We tell this because of the difference in decimal points on these values. That's how we tell the difference. So setting up this machine tool is to establish the workpiece origin for the Z-axis. X0 is factory preset and always comes off of the center line of the spindle. Z0 can be any place from the face of the chuck to the tail stock, and it's entirely up to the operator and the CNC programmer where that's going to be. In order to set the coordinates for Z0, what we would do is first of all move the turret in. So I'm going to select the handle mode. I'm going to select the Z-axis so I can move the turret closer to the workpiece that's chucked in the spindle. I'm going to next index my turret using the turret 1 start, and I'm going to locate it so that cutting tool number 3 is in the cutting position. We're going to use cutting tool 3 for a master tool for the setup in this operation. What we do now is we bring the cutting tool up in contact with the face of the workpiece so that we physically know where the cutting tool tip is going to be as compared to the workpiece on the part. So I bring my spindle in, I'm going to slow my jog rate down. As I bring the cutting tool into this end of the workpiece, I go for an extremely expensive feeler gauge, affectionately known as a piece of paper. And I'm going to establish contact with the workpiece where I get a minimal amount of resistance. What I have there is just a little bit of resistance at this point as I slide the paper between the end of the workpiece and the tip of the cutting tool. At this point, what I want to do is I want to measure the Z-axis position and set that so that that position is now Z0. I choose my offset page from the menu, and I want to look at my work shift, and the keystrokes I'm going to use are M for measure, C for the Z-axis, and 0 because it's the position on the Z-axis that I'm wanting to set. When I press input, it changes the position that the cutting tool is currently setting at to become the workpiece coordinate origin of Z0 for this part. When I go back and look at my position, we will notice that we have a value of Z0 in the CRT. While I'm in the offset page, I want to look at my geometry offsets, and for tool 3, which I believe is the one that's in here, what I want to do is I want to set up my coordinate system, so I'm going to move my cursor to the position for offset 3. Again, I measure Z0 and input, and it establishes the Z tool length for that one tool. It becomes the master tool as being 0. We expect the master tool to be Z0 for this setup. My next step is to manually jog the turret away from the part. I'm going to come up in the X-axis, again going positive. I bring the cutting tool closer to the turret, or to the spindle. I change the X-axis to come closer to the workpiece. And again, using my fancy feeler gauge, I bring the cutting tool down to just touch the outside diameter of the workpiece. I have just a slight resistance on the tip of the cutting tool at the workpiece. With my offset setting for offset 3, because it's tool 3 that I'm qualifying, I want to measure my X-axis position, and the diameter of the workpiece that I'm touching is 1.5 inches. So I'm going to measure it as a value of X, 1.500 inches. When I press input, it updates the value of the offset for the X-axis at minus 1.239, which is calculated by the computer automatically, so that now the computer controller knows the value of how far to move in the X and Z axis for positioning that cutting tool when loaded in the operation of the program. Does that make sense?
Ready.
Ready? Okay, to qualify the next tool in our setup process, what I want to do is jog my turret again so that my X-axis is clear of the workpiece by moving an X plus. I increase my jog rate to 10 thousandths. Move Z. And what I'm doing is clearing the workpiece so that I can safely index the turret to the next tool. When I press turret 1 start, it indexes the second tool to the cutting position. Now what I'm going to do is move my Z-axis in again, move the X-axis so the tool will engage the face of the part, move my Z, drop X just a little bit lower, same feeler gauge. Slight resistance between the part and the cutting tool on the paper. I then turn to my offsets. I press my down arrow, so I'm setting for offset number 4. And what I want to do is I want to measure, the position is Z0, and I want to input. So I press M, Z0, input. What I get on my display is showing that the value for tool 3, which becomes my master tool, has a Z0 value. The geometry offset number 4 Z value is 13 thousandths, which tells me that the tool is in a position that is 13 thousandths different along the Z axis than the original tool that we qualified. To qualify the second tool, we will now move it to the outside diameter of the workpiece and allow the computer to establish the length on that tool. So we go Z plus, just to clear the end of the part. I'm going to go X plus, move Z in, X minus, and slow my rate down, again using the feeler gauge. established the diameter. I've got the contact with the diameter. I go back to my geometry offset. I want to measure my x-axis at 1.500 input because that's the stock size on the part that I'm touching off to qualify. If we were doing a series of parts, and there can be up to 11 outside diameter parts in the turret on this machine, once all of the tools have been qualified using the procedure just outlined, this machine tool would be ready to load the program into the control memory and to load material into the chuck and to hit cycle start, make chips, and hopefully come up with a completed part to blueprint specifications.